All right, so I think this is recording. Let's take a look at this problem. They've given us the sine of angle A, cosine of angle B, tangent of angle C, and there's several problems that all of these relate to. So for number 14, with the sine of C, we're not going to worry about the sine of A or the cosine of B. If the tangent of C is 5 over 2, then we can construct a triangle, and if we let the opposite leg be 5 and the adjacent leg be 2, we can figure out the length of the hypotenuse from the Pythagorean theorem. 5 squared plus 2 squared is 29, so we'll take the square root of 29. And the sine of C then is equal to 5, the opposite leg divided by the hypotenuse. And then if we rationalize that, we get 5 radical 29 over 29. That's one way that we can do it, and that's probably the fastest and easiest way that we can do it. Yeah, that's I don't know. The tangent by the quotient identity is sine over cosine. I could find it indirectly using one of my Pythagorean identities. Let's see if that would work. So I've got a Pythagorean identity theorem that says that the cosecant squared of an angle is equal to the cotangent squared of an angle plus 1. I know that cosecant is the reciprocal of sine. I know that cotangent is the reciprocal of tangent. So if I take the reciprocal of 5 over 2, I get 2 over 5. And if I square 2 over 5, I get 4 over 25. If I add 1, then I can write 1 as, maybe I shouldn't skip so many steps. If I add 1, I've got 29 over 25. So on this side I have 1 over sine squared. If I flip that side, I have to flip this side. And by flip, I mean reciprocal. If we make the assumption that these angles are all in quadrant 1, I don't have to worry about introducing a plus or minus symbol. So if I take the square root of this, I can take the square root of the numerator and denominator separately. And then I can rationalize that, and I get the same answer that I had before. All right, so I hope that helps. And like I say, I would do it the first way. Here, let's take a look at what information is given by the cosine of angle B is 4 over 5. If this is angle B, we could just go adjacent over hypotenuse and recognize very quickly that it's a 3, 4, 5 triangle. The cotangent is the adjacent leg over the opposite leg, which is 4 over 3. And that would be the fastest and easiest way to do it. If we tried to think in some way to use any of the identities that we have, we could do it similar to the last problem that I just did. So let's try that. We know that the 1 plus cotangent squared of b is equal to the cosecant squared of b. And the, oh wait a minute, since that's cosine, I'd want secant. Let's use the tangent, the other the Pythagorean identity. Even though this is cotangent, I'm going to solve for tangent and take the reciprocal, because if they give me cosine, I can take the reciprocal cosine and have secant. So if the cosine of b is 4 over 5, then the secant is 5 over 4. And if I square 5 over 4, I get 25 over 16. If I subtract 1 from that, we'll write 1 with a, as 16 over 16. I'm just taking 1 away from each side to get the tangent by itself. So we have the tangent squared of angle B is 9 over 16. If I, knowing that I made the assumption that angle B is in quadrant 1, when I take the square root, I don't have to worry about putting the minus sign there. I can just take the positive square root. I got 3 over 4, and if I take the reciprocal of that, the reciprocal of tangent is cotangent. So if tangent of angle B is 3 over 4, then the cotangent is 4 over 3, which is what I believe that we had just before. All right. I'll do this one on another video.